So today, more of like theory part. You need to understand about the Parquet files actually. So why Parquet file came into the market and what is the advantage of the Parquet file compared to the other files. So this is one of the interview question, and as well as this is the fundamental or very basic for the Delta and one lake for both I can say. Okay, Delta file format and the one lake date file format for both it is a fundamental I can say. So you have to understand this one because even in the real time as well, mostly you're going to deal with the Parquet files only. See, nothing to do with that one. I mean, you don't need to do anything inside the file, but you need to understand the format of the file actually. Okay. So before that one, I would like to tell you here when was actually it came into the market, and previously what were the different file formats we used to use. So early 70s, we used to use only CSV files, that is comma separated files. Everybody know that one. Okay. Oh, sorry, early 80s I can say, or 90s I can say, early 90s. They used to use CSV file formats only. And after that, in 96 actually XML file format came into the market. You guys know like all web-based applications generates the data in a XML format or JSON format, right? So XML was also not good at that time. I mean, handling point of view, XML is not that good, I can say. Then JSON file came into the market and it has become very popular. JSON file. So it came in 2000, like 2001 and 2002 time. Okay. So this is fine. We were good with these file formats actually, CSV, XML, and JSON formats. I can say out of these three, CSV and the JSON are the famous ones, I can say. Okay. Yeah. So, and after that, and after that, there were three different questions actually. I was just trying to mention here. So, industry was looking something like this actually. Like they started generating companies or like industries started generating huge volume of data where CSV or JSON cannot able to handle that much volume of data. I can say. So they were looking for one new file format. Um, so in such a way that the file should be serializable. Serializable is nothing but the file should store the binary values, I can say. Okay, I'll tell you why we have to consider that scenario in the Hadoop case or in the Spark scenario. Okay, so is the file splittable or not? Okay, when I say splittable, if you take JSON file, sorry, CSV file, we can divide the file into different parts, right? Okay, first 100 records into one part, next 100 records into another part, next 50 records into another part. Like that, we can consider actually. We can split. We can able to split the file. So, can we able to split the XML and JSON files? No, you cannot, because all the records are actually. I mean, the tags in XML or the elements in JSON are actually mapped together. You cannot divide that. Just like that, CSV, you cannot divide the JSON file. Okay, so that is what they are trying to they were trying to look actually. The file should be splittable. And one more thing is how easily we can change the schema of the file. Okay, if at all if you want to add a column, can we add that one? If at all if you want to delete the column, so is it does it support or not? It should be able to support that one. That's what I was trying to say here. So they were looking for the file format which can satisfy all these requirements. Okay, at that time, so our hero came into picture. That is Parquet file format. Before that one, before 2013, so Parquet was introduced. It was developed by actually Twitter people, Twitter and the Cloudera people actually. They combinedly worked on this file format, and later it was handed over to Apache company, Apache open source company, I can say. So Apache introduced that first Parquet file format in 2013. Before 2013 and after 2001, there were like multiple file formats are there, but they were not able to satisfy the industry requirements, I can say. Okay, so we have thrift file format and proto buffer format. So I've never seen these file formats actually, to be frank. I've seen Avro and I've seen RC files. When I was using actually Hive in Hadoop, I was able to check these RC files as well. So Avro still it is good for even nowadays also we are using the Avro. This is especially used for the streaming data purposes. Streaming data. Okay. So Avro and sequence file was Avro sequence file was introduced in 2009. I can say for especially for the big data workloads. Okay. So this file is specially designed for Hadoop workloads only, and this one as well. RC file as well. Okay, this RC file mainly introduced because of the Hive tables. RC full form is row columnar format file, I can say. ORC is nothing but optimized row columnar format file. So the advanced format of RC file is nothing but ORC file. So what are all the disadvantages are there in the RC? They overcome all the problems in ORC file and they introduce this file format actually ORC. Okay, I'll show you this file format as well. Unfortunately, we cannot able to read the data from all these files actually. Okay. Anyway, we are going to deal with that. We are going to we are going to understand about the file formats. Don't worry about that one. So let's focus more on the Parquet file format. I'm going to give some context about the Avro and Warsh also maybe tomorrow and after tomorrow. Okay. So for now, my focus is only on the Parquet file format. Okay. So it was developed by Twitter and the Cloudera people. Okay. Okay. So Siva, this Parquet file format is satisfying all these requirements? When you ask that question, I'll say yes. Yes. Okay. The first one is what is splittable? I told you already, dividing the file into different smaller number of parts is nothing but a splittability. So since this Parquet file is actually storing the data in a row, I can say a columnar format. I can say it's not pure columnar format. I'll talk about that one also. Don't worry. So it's a hybrid file format, I can say. So many of you know how Snowflake stores the data, right? In micro partitions, right? Same concept here also, guys. Even Snowflake also inspired that file format backend that micro partition concept is actually inspired by this Parquet only. We're not sure like backend they might be storing the data in a Parquet format only. We're not sure. Nowhere they mentioned that actually. I told you many times also in Snowflake class as well, they might be storing because all the whatever the behavior we understand in Parquet, right, same behavior we see in like Snowflake as well. Okay, so how the Snowflake is storing the data in smaller partitions or micro partitions, right? Same way, Parquet stores the data in a different row groups, I can say. Here that micro partitions we call it as a row groups. Terminology is changing, that's it here. Since it is storing the data into multiple row groups, we can able to divide that into smaller parts. When I say we can, cluster can divide that one, I can say master node can divide that into smaller parts and it can distribute that data across the cluster, I can say. So that is satisfying that requirement. Parquet file is actually satisfying that requirement. Okay, even other files also we can able to split. Like we can able to split text file easily, or text file or CSV file easily. I'm not sure about the WARC and the sequence files. Park and WARC file columnar formats are they're designed to be splittable. Of course, WARC also is splittable actually. Okay, even somewhat Avro and sequence file are also splittable. Okay. Okay. So the first property is actually satisfied here. I'll discuss in depth about that split, the other things as well slowly. Okay. So next, moving on to the next property, next behavior that they are looking, market is looking was serialization. Okay. So before we go and understand whether Parquet file is supporting serialization or not, we have to understand what exactly mean by the serialization. Why this is came into picture? Why this came into picture? This word came into picture actually. Okay. You know what happened here? Okay. Okay. First of all, I'm just trying to explain about our talk about our definition of the serialization here. Serialization refers converting the objects into stream of bytes. Stream of bytes is nothing but converting them into ones and zeros. Okay. When you say ones, when you convert them into ones and zeros, machine can understand that data easily. See, ultimately, your system has to understand ones and zeros, right? Even if you write Shiva, or even if you write Python, even if you write Hello World, system doesn't understand anything about that. Okay, system cannot understand the English language. System can understand only ones and zeros, binary values. That's it. Okay, serialization is nothing but converting that data objects into stream of bytes, converting them into ones and zeros. And vice versa, we call it as a deserialization, I can say. Serialization, deserialization. Okay. So master node, I can say, converts that into serialized format. Okay. And master node actually transfers logically divides the data into different partitions, right? And each partition has to be transferred to their respective worker nodes, I can say, or executors, I can say. That means your data has to be traveled via network to the other nodes, I can say. See, when I say cluster, actually, in a cluster, all the systems are connected together, right? Connected in a same network, right? What do you mean by cluster actually? Group of systems connected in a same network or not? That is what we call it as a cluster or not? Ultimately, even if you when you say Spark cluster, all the systems connected in a same network or not? That means when you divide the data logically into multiple partitions, the data has to be traveled from one system to another system or not? When you do group by, or when you do like this one order by, the data has to be traveled from one system to another system, right? See, if you try to transfer the data between the system or among the systems in a object format, then it will take more time actually. It will take more time. It will take more time actually. If you transfer the objects as is in the network, because objects are like heavy objects, heavy I can say. So that is the reason why your master node or your Parquet file is since the Parquet file is in a byte format here, so it is very easy to transfer the data between or among the nodes here. That is what we call it as a serialization. Guys, able to understand what I'm trying to say? Say yes or no.
Yes, sir.
Yes, Master.
Yes, sir.
Okay, so when you say object, what is this object, Shiva, actually? See, ultimately, when you store some data in a when you try to read the data from the CSV file or like JSON file or Parquet file, whatever it is, ultimately your PySpark or Python or Java or Scala, everything will be converted into objects or not. So when you say A equal to 10, backend, what will happen? It is going to create actually an object or not? In some memory location, it will be stored or not? That is what we call it as an object. That object will be converted into bytes of streams. That stream is actually stored in that data is actually stored in Parquet format. Okay, I'll talk about that one. So simply what I'm trying to say is object, if you're converting into byte stream, that means ones and zeros. Okay, that we call it as a serialization. Okay. Converting back to the object, we call it as a deserialization. That byte stream converting back to the object, we call it as a deserialization. Okay. Okay. Shiva, what is the advantage of the serialization actually? What are all the different benefits we are going to get ultimately here? Okay, so the first one is efficient data transfer. This is what I was talking actually. See, in Spark, I told you already, shuffling operations may happen, right? When you try to do like white transformations, right? In the case of white transformations, the shuffling will happen between or like among the nodes, right? Correct or not? Did I tell you that point or not? Yes.
Sure.
So, uh, when the shuffling is happening, all the nodes has to coordinate each other. Okay, let me put it in a diagram here. So what I was trying to say, this is your master node. Okay, this is your slave node 1, slave node 2, slave node 3. Okay, let's say I'm trying to group the data based on the department number. I mean, I'm just taking the simple example here. Let's say we have 10th department number, 20th department number, 30th department number data also here. Here also we have, here also we have. Okay, now I'm trying to sort the data based on the department number or group the data based on the department number. Then, what are all the 10th department records are there has to be transferred to the its corresponding node. 20th records number. Okay, so consider this is storing actually 10th department number. It is supposed to store. This one is supposed to store actually 20th department number. This one is supposed to store actually 30th department number. So you have 20th department data, 30th department also here. The 20th department data has to be transferred to this node and 30th department data has to be transferred here. So how it will happen? So from this is one system, this is another system, this is another system again. These systems has to coordinate each other or not. So these two systems actually connected via network or not, via some cable or not, network cable or not. So once you have the 20th department data, 30th department number data in object format, this has to transfer the data via this network to this system or not. So transferring the data directly in object format is costly operation, I can say. This is what I was talking. So that is the reason what happened, while sending the data itself, what master node will do, it will try to distribute the data in a serialization format, I can say. Let's say if you're trying to read the data from the Parquet file, Parquet file is already in the like binary format. So if it is already storing in a binary format, transferring the data in binary format is easy actually. That is anyway in the machine understandable format. See, the data meaning will not change even though it is converting that into binary format. The data meaning is still preserved. Nothing will change here. The only point is it is converting into that binary format. That's it. So this is one advantage with the serialization. Got my point? Everyone understood? Is it like a Greek and Latin? Okay. Hmm. Second one is persistent storage. Yes, this is also good point actually. This is also one of the feature of the Spark, I can say. Okay. Still, I did not discuss this topic. I met to discuss this topic actually. Maybe after the transformations and all done, right? I'm going to talk about this persistence topic. Okay. So, what do you mean by this persistence is, let's say, I'll talk with respect to, I can say RDDs or I can talk with respect to data frames as well. Okay. Let me talk with respect to data frame. Let's say I'm trying to read the data from the CSV file and I'm creating a data frame one on top of that one. Okay, reading the data from the CSV file. And I'm doing some transformation on top of that one. Okay, so I'm creating data frame 2. So I'm creating one more transformation. Let's say here I'm trying to do select operation. Here I'm trying to do filter operation here. So I'm going to create actually df3. So after filter, actually, now what happened, so I'm dividing that into, let's say, only 20th and 30th department data I'm trying to filter. So from 20th, actually, so I'm creating one more, this one, df4. Okay, here, some operation I'm trying to do on top of that one. And here also I'm trying to do some operation on that. So here I'm creating df5, df5. Okay. And on top of this one, if I perform one more operation, one more transformation, I can say, so I can create here df6, okay, here df7, like that. I can keep on creating this df6 and df7. I can keep on creating different data frames based on my requirement. Okay, see, if something goes wrong here, or if at all, if you're recomputing the data at df7, what it has to do? What it has to do? It has to, its df7 parent is df5. It has to recompute this one. Df5 parent is actually df3, and df3 parent is df2. Df2 parent is df1. So it has to start that data loading part again from top to bottom or not. Okay, see, initially it got created. If something happened, or if at all, if you want to recalculate this one, then what happened? Let's say you're trying to read 1 TB of data here, 1 TB of data. So if you want to redo that activity here, again you're reading 1 TB of data and you're creating DF2 and you're creating DF3. On top of that one, DF5 you're creating, DF7 also you're creating here. So you're doing the same operation once again, right? Instead of that, what we do is, if we can able to preserve or store this DF3 data at some place, even if something goes wrong at the child nodes, it doesn't need to calculate, or it doesn't need to recalculate from the first step onwards. So this DF3, we are storing physically in our RAM memory or in the hard disk memory, in the cluster, that too in the cluster. This is what we call it as a persistence, preserving the data, I can say. Okay. So if you're not storing the data in if you're not storing data in a serialized format, that means if you're storing the data in a raw format, let's say you're reading the data in CSV and you're storing the data in the same format, then it will occupy more space. More space. If you're reading 1 TB of data, 1 TB of RAM is required. That is not possible actually. 1 TB of RAM is not possible, right? Or 1 TB of hard disk memory is also required. Of course, that is possible, but we don't store much data in the hard disk actually. So storing that intermediate data is nothing but a persistence. Okay. Anyway, once again, I'm going to discuss about this topic. At that time, I'm going to give like more examples about this one. For now, you just try to understand storing that intermediate results in a RAM memory or the hard disk memory is nothing but a persistence or cache. Cache concept in Snowflake is there. It's the same way here also. But there, the concept is little different. Here, it is little different. Okay, so even for this one also, we need serialization. Okay, so cross-language compatibility. This is also good point. So you're writing your code in Python format, Python language, Java language, Scala language, R language. You write it any language. Serialized data is understandable by any language. See, one point I told you, ultimately, your Python objects has to be converted into Java objects, right? That is what I told you when I was explaining about the Spark architecture. Py4j, one of the separate module is there, which can convert actually Python objects into Java objects, right? Because your Spark framework actually understands only Java objects. Okay, so you write it any language, um, data can be understandable by any language here. That's what I'm trying to say here. So if the data is serialized in one language, that is easily understandable by other language because the serialization concept is same across the languages. Okay. Next advantage, um, broadcast variable. I've already discussed this one. This is separate concept actually. I'm going to talk about that one also. Um, for now, I'm just skipping this one. Okay. This is similar to your cache topic that I've explained. Okay. Uh, okay. So what are all the different serializations like supported by Spark? There are only two types of serialization, guys. If you don't specify anything in Spark, actually by default, Java serialization is enabled. If you don't specify anything by default, Java serialization. That is one of the serialization technique I can say. Okay. So using Java's object output stream. That means objects will be converted into bytes of streams actually. So that is a framework in the backend which can convert the objects into stream of bytes of streams. Okay. So if at all, okay, Java serialization is good for less volume of data, I can say. If at all, if you're handling huge volume of data in your project, then like what Spark recommends is better use like cryo serialization. This is recommended by Spark only. It's not recommended by me. So you just need to import some of the libraries and you just need to enable them in your program. That's it. Okay, so this will what this one does is see all these are actually frameworks. All these are like embedded within Spark framework, I can say. So based on your requirement, you just need to enable them. Hey, Spark, use the cryo serialization for my requirements. Then based on that, it will enable that framework. So Catalyst Optimizer is also one of the framework I can say. So by default, it is enabled. Whether you need it or you don't need it, by default, it is enabled. So it's a combination of different frameworks, I can say. Okay. So this Cryo is also a Java serialization framework actually that focuses on speed, efficiency, and user-friendly API. So it focuses more on the speed because you're dealing with a huge volume of data, right? So speed is also important. Efficiency is also important here. So if you're dealing with the huge volume of data, Spark recommending is actually enable the cryo serialization. To be frank, I never use this serialization in any of my real-time scenarios. Mostly Java serialization. See, explicitly we don't enable this one. By default, it is enabled in the backend. We don't do anything with this one. And if you are dealing with a huge volume of data, if the things are not in your control, then think of like enabling this cryo serialization. Clear? Okay. So one very good point I can talk about Parquet file is, let's say, let's say you have like 1 GB of data in your local, okay, and you're reading that 1 GB of CSV file. That too, I can say I have 1 GB of CSV file is there. Okay, I'm reading the data using data frame API, that is spark.read.csv of that path I'm just mentioning. Okay, and after that, I'm writing this. I'm not doing any transformation. As is data, I'm writing into Parquet format. Do you know what is the size of the target file? Do you know what is the size of the target file? Okay, you'll get 200 to 300 MB of data. That's it. 200 MB to 300 MB. You'll get 300 MB. So what is happening here? 1 GB data is getting converted into 200 MB. Are we really transferring the entire data or not? Absolutely yes. Then what is happening, Shiva? Why it is only 200 MB? So that is the beauty with the Parquet format. So it is compressing the back and it is actually following the compression techniques. Okay, you know what happened when you write the data to the Parquet format? It eliminates the redundant information. Redundant information. What do you mean by that one? So it follows the encoding technique in the backend, encoding and decoding techniques. You know what happened when you try to encode and decode the data here? Let's consider we have employee data. We have employee data in a file. So employee number and employee name anyway unique. Okay. Employee salary can be repeated. Employee department name can be same, right? See, let's say I have 1 GB of employee file. Employee, see, maximum in an organization, you'll be having 10 to 20 departments, right? I- Hardly 50 departments. Okay. If you go with the higher extent. Okay. So in 1 GB file, if if 50 departments are continuously repeating here, what will happen? Your Parquet file encodes them in the backend. Encodes them in, let's say, HR department is there. So wherever HR is there, it will simply remove that HR, or finance department is there, or procurement department is there. Okay, like that, wherever that procurement department is there, it will remove that procurement word and it will try to assign some value to that one. Let's say 01, 02, 03, 04, like that. It will encode some value. It will assign some value to that one. And wherever that procurement is there, it will simply replace that one with the 01. Then what will happen? What will happen? Storing procurement word is easy way, or storing only 01 is easy. While you are reading the data, of course, it decodes the data. You don't need to worry about that one. My Parquet file will take care of that one. Why do you worry about that? Are you guys getting my point here?
Yes, sure.
Sure.
Okay, so because of this encoding and decoding technique, because of this compression technique, actually, the data is actually 1 GB is actually getting converted to 200 to 300 MB. And you know the compression ratio, how much you'll get? 60 to 80% compression ratio you'll get. Storing the data in Parquet format will consume very less space, I can say. That is the reason, even in my project also, we are reading the data from the Oracle table. Okay. Whether it may be 1,000 records, 1 million records, 10 million records, 1 billion records, irrespective of that, we are writing the data into Parquet format because the storage is easy actually. So we can simply avoid the storage cost here. If you try to store the same data in a CSV file, it may occupy more space. And I'll talk about some more advantages of converting that into Parquet format.
Shiva, while storing it is decoding, right? And
Hmm.
while reading, again it will encode, na? You need to encode
While write,
zero.
when the file is getting generated, it will encode the data and write it. While reading the data from that one, it will decode it.
Okay, sorry.
This decoding and decoding information is actually stored in the footer, footer of the file. Now tell me, what are all the advantages you understood so far with the Parquet files? The first point is the one I've told you now is compression ratio. Compression ratio, how much you can achieve?
60 to 80%.
60 to 80%, depending on the data. Sometimes you may achieve only 60%. Sometimes you can achieve like if you have more redundant data, you can achieve even 80 to 90, close to 90% as well. That means 1 GB of CSV data, Parquet files stores within 100 MB of data. That's it. Parquet file takes only 100 MB of data. That's it. Okay. So this data sizes, this is what I was telling you. The data sizes can be reduced through serialization for several reasons. One is removal of that white spaces and formatting and binary encoding. That this is what I was telling you. Okay, data encoding, and there are different encoding techniques are there. We don't need to understand more about that techniques, but we just need to understand. Okay, the encoding will happen in the backend. Okay, or dictionary based compression also. This is also one of the technique actually. Okay. Ah. Now, very good and very good feature of Parquet is columnar format. It stores the data in a columnar format. Okay. Now, what is the difference between row-based data file format or columnar-based data file format? What happens? Okay, if you want to understand like more about this one, you tell me what is the difference between the traditional RDBMS databases and the Snowflake. Okay, storage point of view, you can talk. I'll relate the same thing to the Parquet file. Come on.
Columnar data.
Hmm. Columnar file format, columnar data.
Um,
What is the advantage of like storing the data in a columnar format um, in I can say Snowflake?
Performance.
Instead of
Ah.
picking the entire data row, we can pick the specific column
Mhm.
directly.
See, all the data warehouses are like most of the data warehouses are columnar databases only, right?
Yeah,
You
yeah.
take Snowflake, you take this one AWS Redshift, you take this one as well. What is that? Teradata. All these are columnar formats only. Why they are good? Why all the data warehousing databases follows the columnar database? See, ultimately, what is our goal actually? What is the use of the data warehouse? We analyze the data, right? We write SQL queries and we analyze the data, right?
Performing.
So you're performing, you mostly you're going to write select commands only on top of the database, on top of the tables actually. That means you're reading the data. Retrieval will become very easy if the data is stored in a columnar format. Same concept you try to apply in a Parquet file format as well. Parquet file formats are mostly used for the retrieval purpose, I can say. The data reading is very easy from the Parquet file. Okay, now how it is going to store the data, I'm going to talk about that one here. Okay, so let's consider this is the row-based database or row-based file format, I can say. Okay, this is my table actually. At front end, you can see the data like this, I can say. In a database, when you query, select star from some table, or when you try to read the data from some file, the data looks like this. Rows and column format like this. These are all the rows. These are all the columns, I can say. Customer name, product ID, sale amount, and transaction data. Okay. So what happens, in a row-based one, it stores the data like this. Okay. So this entire row at one memory location, this entire row, okay, like this. Emma, product 100, product price, and product purchase date, something, or ship date like that. We are showing some date here, and this entire data is actually stored at one place. Okay, and next record immediately follows that, follows the first record. Okay, so it is storing actually Liam product 2, 79.99, 2018, something like that. It is storing. Okay, and third product, fourth product like that. It stores the data in a record format like this. try to understand. Even MySQL, Oracle, your SQL Server, all those databases follow the same concept. Backend, it stores the data records like this. When you do select star from table, it is going to scan all these columns actually, the entire memory location actually. Getting my point? See, I'm not doing anything. I'm not doing any wonders here. I'm just trying to tell you how traditional database is actually storing the data in the backend. Because uh, this is closely related to your Parquet file format, backend storage. Okay. Now, so this is what I was talking in a diagrammatic way. If you want to understand, it stores the data like this in rows format in the backend memory location. Columnar storage actually stores all the columns at one place actually. So last name at one place, first name at one place, email at one place, phone number at one place, street address is at one place. Okay. So or if you want to understand more about this one, this is your table actually. Okay. This is your table. These are all your columns, column 1, column 2, column 3. These are all your rows. In the row-oriented file format or row-oriented databases stores the data like this. 1, 2, 3 at one place. 4, 5, 6 immediately follows that. This is row 2. This is row 3 and this is row 4. Columnar-oriented format, 1, 4 at one place. 1, 4 at one place. That means column 1, column 2 value. 1, 2, sorry. 1, 1 second, 1 second, 1 second. It divides that into multiple row groups, I can say. Okay, in this row group, 1, 4, that means related to this data is actually getting stored here. 1, 4, 2, 5, 3, 6 is actually storing here. And in the second row group, 7, 10, 8, 11, 9, 1 is actually storing at one place. Okay, Siva, why are you talking about the same thing again and again here? Okay, I'll talk about that one here. Here, so the columnar database actually stores the data like this. Okay, all the customer names at one place, all the product names at one place, all the prices at one place, all the dates at one place. Okay, you know what happened when you do select, let's say, customer name, comma product. Okay, from some table, so and so table, ABC table or XYZ table. That is my select query. Now tell me, what happens if you try to execute that query against to this kind of storage and this kind of storage? Are you getting my point?
Yeah, sure.
Here
Hmm.
we need to go each and every row.
Exactly. Exactly. Every row we have to scan, right? Whether you're reading the data of the other columns or not, irrespective of that, we have to scan the entire memory or not.
Yes.
Correct or not? Correct me if I'm wrong. Yes. What happens here in this case?
Only name and
Product.
product.
See, it is scanning only, like it's not scanning the entire memory location, right? See, and that one more thing you have to understand. See, Parquet format does not follow pure columnar format. I am not saying that all, let's see, if you have 1 million records, all 1 million names are not stored at one place. Don't think that. All the 1 million products actually doesn't store at one place. No, this is not following the pure columnar format. This is actually following the, I think I have somewhere. Yeah. So pure row-based format stores the data like this. A1, B2. Let's say your data is like this in your table. First row is actually this one. Second row is actually immediately follows that. Third row immediately follows that. Pure columnar based formats. What happened? ABC. If you have 1 million records or 1 billion records, irrespective of that, all the entire column data is stored at one place. Entire second column data is stored at one place. Entire third column data is stored at one place. Okay. So hybrid based formats actually, you know what will happen? it doesn't follow this one, it doesn't follow this one. It follows mix of these two, I can say. Okay, that means indirectly it is going to create actually row groups. I'm relating this one to your Snowflake micro partitions. So if you have 1 million records in your Snowflake table, all 1 million records are stored in records at only one partition, or is it going to create a multiple micro partitions? The backend.
Multiple micro partition.
So what is the each memory chunk? What is the size of the each micro partition?
128 MB.
No, 5 to 50 MB, right? In a compressed format in Snowflake. Okay, some number. Okay, see, original value is 5 to 50 MB in a compressed format if you talk. But here you can consider, let's say, 20 MB or 30 MB like that. Consider for some time. Okay, so 20 MB of data, first 20 MB of data, it will try to store at one place. Second 20 MB of data stored in the other row group. Third 20 MB of data is stored in other row group like that. So it doesn't follow pure columnar based format. It doesn't follow pure row based file format. It follows the hybrid file format, I can say. Okay, now tell me what will happen in this case and what will happen in this case. If you try to read the data from row based storage, it has to, whether you're reading the data from the third column or not, it has to scan the entire data. But in this case, actually, if you're storing the data like this, in this particular row group, it is going to read only A and B here. Let's say you're reading the first column is customer name. It doesn't scan this one directly because, and that too, let's say if you're filtering only A here, you know what will happen? So how your Snowflake is actually following the min and max values in the metadata, right? In the same way here also, it for each and every row group level, it stores the min and max values. Somewhere I have that one. One second, I'll show you that. Just a second. Yeah, like this. It stores the min and max values. If you are filtering, let's say, only customer A, it will come to this row group and it will ask this row group, hey, do you contain that A related data or not? So if this row group is saying, hey, I don't have that one, then it will not scan this particular row group. It will come to this one row group, hey, do you have that A related information or not? Then if this one is saying no, then it doesn't scan this one. Whichever the row group is saying yes, then only that particular row group is scanned. So what is the advantage of that one? Faster retrieval or not?
Yes.
Yes.
Same concept here also. See, that is what I was telling you. Even Snowflake also took the inspiration from this file format only. Indirectly, it is also following the same thing. So if you're scanning, like, let's say, department number less than 5, then this partition will be scanned and this partition also will be scanned. The unnecessarily doesn't scan the other micro partitions, other row groups, right? The retrieval is very fast. Okay, so this is what I was telling you. See, and that too at each, not only at the like a single column. If you have like 3 columns here, let's say all the product IDs are storing. See, consider this is one row group. In one row group, let's say all the product IDs are storing here, revenue is storing here, product type is storing here. At each column level, min and max value is stored. Let's see if you're writing this one, select product ID, comma sum of revenue from the products, group by product ID. If this is the if this is the query, then what will happen here? What will happen here? So let's say it will not scan this particular column actually, because All the product IDs are stored at one place. All the revenues are actually stored at one place. All the product types are stored at one place. It will simply skip this particular part, and it is going to scan only these two. It doesn't need to scan the entire memory in that case. Okay. Am I discussing too much?
Yeah, sure. So for each column, it maintains metadata to it, and while scanning, it will refer that, right?
Correct.
That's what.
Correct.
And it stores min and max of it
Max
in
values
the
of each and every column level
every
information.
column level.
In
So
at each and every row group level.
row group level. Oh.
Now tell me, um, if you take one, this one, okay. If you take one Parquet file, now tell me what are all the base elements inside this Parquet file? How the data is distributed here?
Columnar format.
Columnar format only, but what are all the base elements in this one? What is this one? Row groups, right?
Row groups.
This is
Yeah.
row group 1. This is row group 2. This is row group 3, and so on. Based on the size of the volume of the data, the row groups will be decided internally. That you don't need to control that. Okay, inside row group 1, what do you have actually? Column 1, column 2, column 3, column 4, and so on, depending on the number of columns, right? Here also column 1, column 2, column 3, and so on. So I have the diagram. I'll show you that one here. Did you get my point here? Somewhere I have that one. 1 second. Oh, this is this one, right? 1 second, 1 second. I have that one. I have that. I have that. Where is that? Where is that? Where is that? Where is that? Just a second. Huh? This is what I was talking. Okay. So this one also you can understand. So in a file, you'll be having actually row group 0, row group 1, row group 2, and so on. Multiple row groups are there. At each row group level, we have column A, column B, column C, and so on, multiple columns. Inside this column, again, page 0, page 1, and so on, page ends. It will store. At each column level, min and max value will be stored in the footer part actually. In the footer actually, what it maintains, row group related metadata, row group 1, I mean, all the row groups related metadata will be stored. Clear?
Min and max value maintained by internal, right?
Yeah, internally. That we don't have any control on this file format generation, guys. This is open source format. Back and it uses the Java, definitely. Okay. Java does that one actually. If you want to generate Parquet file, you have to have Java in your local, in your system, I can say. So every Parquet file contains header part, footer part. Header means like I'll tell you like here you can see every header contains four byte magic number. I'll show you that one tomorrow. I'll generate one Parquet file and I'll try to show you what it is generating in the header part. Okay, so we call this one as PR1. We call it as a 4-byte magic number, and every Parquet file ends with the PR1. Every Parquet file starts with the PR1, ends with the PR1. You know what is the advantage of this one? Par1 here. Par1 is nothing but Parquet. You know what is the advantage of that one? So, um, though it is like ending the file format with the dot parquet, but your framework doesn't understand whether it is really a Parquet file or WARC file or some other file, because all these WARC file and the Avro file all are like serialized files only. Your application has to understand whether it is really Avro file or WARC file or Parquet file or not. So in order to understand it, every Parquet file has to start with the keyword called PR1. It ends with the PR1, so that your application understands that okay, this is a Parquet file. I'll show you this one practically. Tomorrow I'll generate that Parquet file and I'll show you that. I think I do have it in my local. Let me show you that. PySpark, datasets, Parquet. Yeah, this is one sample Parquet file that I've created for your previous batch. Let me open this one. See, are you able to read like something from this file? Can you read? Can you read the data from this one?
No,
No. Why? Why you're not able to read that? Because it
Binary.
is in a binary format. It's a binary
not a
file, I can say.
data format.
Hmm. It's a binary format, a serialized file, I can say. That is the reason you're not able to read anything. Okay. And I told you, right? Every Parquet file starts with a keyword called PR1. And see here, it is starting with PR1, it is ending with PR1. This is the this is generated by Spark only. This file is. Okay. So I was telling you, right? Like backend, it stores the metadata, and along with that one, it also stores the schema, guys. Schema of the file, guys, actually. This is what the schema, where it is starting. Fields, see here, fields. It is starting here and it is ending here. The fields of each and every column. Sorry, the fields of the file, actually, I can say. See, in this file, we have employee number and its corresponding data type is integer and it can be nullable, true. And employee name we have, gender also we have, like job also we have here, and manager also, like that. Multiple columns are there here. Okay, and that too, by default, when you see, you can generate plain Parquet file as well. You can generate the compressed Parquet file as well. What is the difference between the plain Parquet file and the compressed file? When you compress, what will happen actually? When you compress something, what will happen?
Size will
See,
reduce.
it reduces the size, right? See, that is the reason why in any application, mostly Parquet files are like actually compressed files. That too, the compression technique is snappy compression. That is one of the how you have zip compression, gun zip compression is there, right? In the same way, snappy is also one of the compression technique. It follows this is the default compression technique, I can say. That is the reason why file extension we got part hyphen 000 00000. You know this, what do you mean by this one? And this is the transaction number. Okay. And when I say transaction number, process ID, I can say. And dot snappy dot parquet. It's not parquet, it's a parquet. T is silent here. Okay. Uh, second. Yeah. So this is about, okay. Now tell me, uh, one more thing here.
Yesterday you said partition by
Okay, remind me that one tomorrow because I'm not doing any practical part right
Parts.
today. I'll do that one tomorrow. Okay, yeah. One more thing here. I told you, right, the advantage of storing the data in a columnar format. What is the advantage you're going to get? The readability, right? Readability and the for the faster reads, I can say. Okay. Now tell me, row-based file formats are good for what? Let's say in a database, you're storing the data like this. Okay. So first record, second record, third record, fourth record, like that. Okay. Now, if that is the case, actually, if at all, if you want to perform any DML operation on top of this data, then tell me, uh, a row-based file format is easy, or row-based databases are easy to do the DML operation, or columnar-based ones are easy.
Row-based will be easier.
Why? Okay, your point is absolutely correct. Okay, that is correct answer. But why?
We need to update every record, right?
Mm, Let's say you're updating only 10th department data. Let's say you're inserting the data in that case. Best example, inserting the data.
So
DML
we
operation in the sense inserting the data. See,
we
when you
need to
insert
insert
new
every
records,
column.
it simply appends that whole record at the end of the previous record, right?
Hmm.
See, it keeps adding that, appending that data, right, at the end of the record, last record. See, appending is easy, or arranging this data again in this format is easy. Columnar format is easy.
Appending easy.
That is the reason why for DML operations, actually, for DML operations, especially the row-based file formats or the row-based databases are quicker. Okay. I told you already this point in Snowflake. I don't know how many of you followed. The DML operations are very costly in Snowflake. Did I tell you that point?
Yes.
This is the reason actually I told you. Okay. Yeah. So we are almost done with the Parquet file. I don't know what point I missed here. 1 second. Let me go through my. uh, Yeah. So I told you, right? Like when you compare with the CSUL, Parquet takes 87% less space and queries 34 times faster. 34 times faster. They tested it actually. They tested on top of 1 TB data on S3 storage. Parquet supports these compression techniques, guys. Snappy, gzip, and LZO. All these are compression techniques only. Okay. So this is one of the interview question actually. What is the can you compare CSV file and Parquet file? That is what the question they will ask definitely. Now, can you come up with the points tomorrow? At least 3 to 4 differences.
Parquet, what will you?
Difference between the CSV file and the Parquet file.
Parquet.
Yeah.
Okay, sure.
Yeah. Okay. So how many of you did yesterday's exercise that I've told you? Reading the data, capturing the bad records, and sending it over the email.
No, sure. I will try in the weekends.
Yeah, sure. You guys can try that one. Yeah.
Yeah, weekend will try. Yeah.
Okay. Yeah. So we are done with this one. I think I've already discussed this slide as well, and this slide as well. I told you already. Every Parquet file starts with the PR1. We call it as a 4-byte magic number. Okay, and the presence of PR1, first 4 bytes of the file, where to confirm the file is a Parquet file. This is what I was telling you. Your application will understand it easily. Okay, it's a Parquet file. Okay, so if your upstream is not generating the Parquet file properly, then it will not generate the par1, right? Then okay, then it can understand, okay, the file is not in a proper format. So for that only we are generating that par1. Okay, so and on top of that one we have blocks. Inside the blocks
Mummy is
actually,
coming.
okay, on top of that one we have like row groups. Inside that row groups column chunks are there. And finally we have the footer as well. In the footer we have actually, so like this actually I'm talking. So file metadata, par1, at the start of the file and the end of the file. Inside that file data actually we have, in the metadata, in the footer part I can see only metadata is stored. Okay. And par1 is stored actually. Okay. This one I've already discussed, max one, min one, predicate push down already discussed. Okay. So you guys can come up with the differences between the CSV file and the Parquet file. At least four differences tomorrow. Okay. You can check it in ChatGPT or Perplexity or like internet or YouTube. Get it wherever you want. Okay. That is one of the interview question, guys. That is the reason I'm asking. Okay. I have the differences, but I don't want to discuss at this point. I want that answer from you only.
Okay, sir.
Okay. Okay. So that is about today.